Hello everyone, this is Dnyaneshwar Sanap working as an assistant professor in the Department of Chemistry at Maratha Vidya Prasarak Samaj, Arts, Commerce and Science College, Dindori. In this video lecture, we will discuss about the remaining two structural effects. The first one is hyperconjugation effect and second one is electromeric effect. Let us see first hyperconjugation effect. Basically, hyperconjugation effect is an modification of an resonance effect. It influences the physical properties of a molecule. Hyperconjugation involves basically the delocalization of sigma electrons. As we see in the resonance effect, the delocalization of pi or non-bonded electron, that is lone pair of electron, is take place. But in hyperconjugation, the delocalization of sigma electrons. This is the major difference between the resonance effect and hyperconjugation effect. Let us see some example in which the decreasing order of inductive effect. The first example is tertiary butyl group, in which the carbon is bonded to 3 methyl groups, that is CH3 and CH3 here. This tertiary butyl group having maximum inductive effect because of presence of 3 methyl group surround the one carbon atom. Then the isopropyl group, that is CH3 hydrogen and CH3 here. This having less inductive effect than tertiary butyl group for the any electron deficient species. This isopropyl group having more inductive effect than that of ethyl group, that is CH3 hydrogen here and hydrogen here. And this will be exert the lesser inductive effect as compared to the first two. This ethyl group having more inductive effect, more positive inductive effect than that of CH3 group, because here all 3 hydrogens are surround the carbon atom. This is the order in decreasing manner for the inductive effect. But when we consider or think about the hyperconjugation, the order of electron donating group is somewhat different. When this group is attached to the unsaturated system, that is carbon-carbon double bond system or benzene systems, or carbon-carbon triple bond system or carbon-nitrogen triple bond system at alpha position, the order of electron donation is different. Write the number for this order: first, second, third and fourth. For inductive effect, the order of electron donation is like this: first having more electron donation capacity than that of second, the second having more than that of third, third having more than that of fourth. This is for positive inductive effect. But for hyperconjugation effect, when this substituent at that position is attached to unsaturated system or benzene system, then the order of electron donation via hyperconjugation is completely reversed. The fourth substituent having maximum hyperconjugation effect than that of 3 or third fragment, then that of second, then that of first. Let us see this how it is possible. When alkali group at alpha position having maximum number of hydrogen, let us take the example of CH3 group at alpha position of an unsaturated system. That time what happened, let us see. In this case, this alpha carbon having 3 hydrogens, that is first hydrogen, second hydrogen and third hydrogen. This 3 hydrogen undergoes the hyperconjugation and shows the maximum electron donation via positive hyperconjugation through the sigma bond. And this hyperconjugation effect is more predominant than that of inductive effect. Let us see how the hyperconjugation effect is take place. All this carbon-hydrogen bond having 2 electron in its like this. This 2 electron is resonate over this carbon-carbon bond, and this bond get open on the alkene terminal, and the new structure is formed in which there is formation of charge structure like this. The double bond is shifted in between carbon number 2 and alpha carbon, CH2 minus and H plus here. This hydrogen atom is not completely detached from this carbon atom. It is in the vicinity of this carbon atom. Keep in mind. Okay. In this case, basically, the hydrogen at alpha carbon atom does not become free, but it remains in the vicinity of carbon to which it was attached. In the above structure, the hyperconjugation for only one hydrogen is shown. The similar hyperconjugation is possible for these 2 remaining hydrogen, that is hydrogen 1 and hydrogen 2. That's why the number of hyperconjugation increases. It resulted the number of canonical structure also increases. As we see, the order of electron donation via the inductive effect is like that. This tertiary butyl group having more inductive effect than that of isopropyl group, than that of ethyl group, than that of methyl group. But this order is completely reversed in the hyperconjugation. Here we already write the order of hyperconjugation effect for the donation of electron. It is because of the number of hydrogen increases at alpha position, it resulting the number of canonical structure is maximum, and that's why the methyl group shows the high electron donation via the sigma bond than that of ethyl group, than that of isopropyl group, and that of tertiary butyl group. This is the order in decreasing fashion for the electron donation by using hyperconjugation. Sometimes this hyperconjugation effect is also called as electron donating resonance effect, but it involving the sigma electrons from alpha carbon hydrogen bond. In shortly, it is called as electron donating resonance effect via the sigma bond from alpha carbon hydrogen bond. This is all about the hyperconjugation. The second structural effect is electromeric effect. Basically, electromeric effect is a temporary effect which shows mainly by the unsaturated system or multiple bond systems or groups in the presence of reagents. That means here is a basic requirement for the electromeric effect is requirement of reagents. Requirement of reagents. Basically, reagent is electron deficient. Electron deficient always. Let us see some examples. When nonpolar unsaturated system is treated with electron deficient species like as Lewis acids, The example of Lewis acid here is BF3. When this nonpolar system is treated with Lewis acid, it undergoes the polarization because of donation of electron density from carbon-carbon double bonds towards the boron atom and forms the new intermediate like this, that is also called as pi complexes. This electron density is donated towards the boron atom. This donation of electron density in BF3 is because of the vacant orbital present in the BF3. Let us see first of all the structure of BF3. Basically, boron having valency 3 here like this, and the structure is trigonal planar, and in BF3 molecule there is one vacant orbital perpendicular to this plane and which is responsible for accepting the electron from carbon-carbon double bond and forms the pi complexes. This vacant orbital or this orbital is accept the electron because around the boron atom only 6 electron is present in 3 BF3 bond, and that's why to complete the octet this double bond is easily donate the electron in vacant orbital of boron and forms the pi complexes. Further, this pi complex convert into separate charges by complete shifting of pi electron in vacant orbital of BF3. Let us see the exact structure of Ionic species. Boron having negative charge and a remaining part is like this, and this carbon carries the positive charge because this bond is shifted here now, and this newly formed structure called as polar structure. Let us see the another example of carbonyl molecule. Basically, carbonyl is also the unsaturated system. When this carbonyl moiety is treated with any acids or Lewis acid like as AlCl3, this double bond to donates its electron density to the aluminium because aluminium having vacant d orbitals in its valence shell, and that's why it forms the new pi complexes. And the structure of pi complex is like this. This pi complex is further converted into charge species by complete shifting of electron density towards the aluminium. Aluminium carries the negative charge and this carbon carries the positive charge. This is the polar system. That means sometimes reagent is responsible for induce the polarity in non-polar bonds. It may be multiple bond or it may be single bonds, or sometimes it enhance the polarity of some polar bonds. It may be single or may be double. This electromeric effect of polarization of bonds in the non-polar as well as polar compounds or in the molecules is a temporary effect, because when we remove this electron deficient species or Lewis acids from it, the electromeric effect is disappear. Though it is temporary effect, it is useful in the inducing the polarity or enhancing the polarity of a multiple bonded system during the many reactions. This is all about the electromeric effect. Thank you for watching.